Welcome to our teacher app. I am your math teacher. Today we are going to discuss about the real numbers of 10th class. So real numbers is nothing but, considering all types of numbers in this particular set. What are all numbers of type? All numbers of sets means basically we are discussing about the natural numbers, whole numbers, integers and real numbers or rational numbers. So rational number, a number which is in the form of p by q. That means all the fractions. All the fractions will be in that particular set. Some numbers which we are unable to express in the form of p by q also are there. What are the numbers is suppose if you take 1.01, 001, 000, like that, if it keeps on increasing, so what happens? This fraction will not end, no repeating values. So such fractions we cannot express in the form of p by q. So such numbers irrational numbers we will call. So natural numbers, whole numbers, integers, rational numbers and irrational numbers. Irrational numbers, if you consider root 2, root 3, root 7, all such numbers, they doesn't have a particular value. Root 2, if you consider 1.414 and so on, so it doesn't end anywhere, it doesn't repeat. So that numbers are called irrational numbers. So irrational numbers, rational numbers and remaining number sets all together, if you keep that big set, is called real numbers. So in this topic we will discuss about the first one is Euclid division lemma. So first one is Euclid division lemma. So what is this one means? If you consider Euclid division lemma, generally you know LCM and HCF or LCM and GCD. LCM is nothing but least common multiple. GCD means greatest common divisor. So how to find GCD with the help of Euclid division lemma means this is the formula. A is equal to BQ plus P is the formula. So that means it is nothing but it is called a division rule. So now when you take two numbers 40 and 60, how to find GCD or HCF means you take 60 is equal to 40 into 1 plus we will consider as 2. So if this procedure, if you rotate, now we will consider this 40 here. So the next highest number again we will split in the same way. So where you will get 0, so that value will be considered as a GCD. So this is with the help of Euclid division lemma. Another way you will find the factors for the both numbers, and with the help of the factors also we can find GCD, and with the help of the division. See, so for 40 and 60, if you divide with 20 2 times and 3 times, so this 20 is HCF. If you multiply the three numbers, it gives LCM. So the relation between the HCF and the GCD and two numbers, see, either LCM or GCD, whatever it may be, we will find with the help of the numbers only. So the two numbers are, if you consider A and B, A into B is equal to LCM into HCF is the formula. That is about the first topic which we discuss in this chapter. Now coming for the second one is about irrational numbers. So how to prove irrational numbers? See, second one, proving of irrational numbers. Irrational numbers. So what are irrational numbers? Root 2. A number which we are unable to express in the form of p by q is called irrational number. So we have to prove irrational number root 2 as irrational number. How to prove means by an induction method we will go. That means we will consider root 2 is a rational number. So we will consider root 2 is a rational number. So according to rational number, root 2 can be expressed as a p by q. But in p by q, after simplifying all the lowest factors, we will get a c by d. So c by d, there is no common factor other than 1. So that if you split into different type of theoretical notation, so you will get there a contradiction. So we are getting root 2 is irrational definitely, but what we have taken root 2 is rational, that is a contradiction what we are taking factor. So in such a way we will prove root 2 is irrational. Root 2 is irrational, root 3 is irrational, root 5 is irrational. Like that we will prove the first example in this topic. And a combination of elements 2 plus root 5 is irrational, that also we will prove. 2 root 3 is irrational. So we will definitely try to prove all these numbers as irrational numbers. And coming for the last topic in this chapter is logarithms. Logarithms. So logarithm is nothing but the vice versa of an exponential notation. if you take a power x is equal to n, this is called exponential notation. Exponential notation will be converted into logarithmic notation. Just nothing but this x will be the value which we are finding in the logarithmic notation. So x is equal to log n to the base a is the definition. So if you convert exponential notation into logarithmic notation or logarithmic notation into exponential, these two are called vice versa. So now here base, if nothing is given, we will consider it as a base 10. So now in this logarithms, main important formula three are there. The first one is log xy, second one is log x by y, and the third one is log a power m. Before going to discuss about these three, so main two important notes are there. The first one is logarithmic value of 1, logarithmic value of 1 to any base, its value is 0. Logarithmic value of 1 for any base, its value is 0. And coming for the next one, log of a number to the same number, its value is 1. So these two are the important notes in this topic. Now coming for the log xy formula, log x plus log y is the formula. Second one is log x by log x minus log y is the second formula. Third one is this 3 comes in front of the logarithmic value, that is m log a is the formula. So with the help of these three formulae, we will try to sort out some examples in this topic. So in this first chapter, first we will discuss about the Euclid division lemma, and the second one we will discuss about how to prove irrational numbers, and the third topic is logarithm. So these three are the important areas which we discuss. Now we are going to discuss about real numbers, some important topics in this chapter. So what is a real number? See, before going to know real numbers, basically we are having four fundamental sets, that are natural numbers, whole numbers, integers, and rational numbers. So apart from the rational numbers, irrational numbers also will be. So what are rational numbers? A number which can be expressed in the form of p by q. P by q is called a rational number. That means the number we are able to express in the form of a fraction. So more than that numbers, some numbers will exist which we are unable to express in the form of p by q. What are that numbers? Suppose if you take suppose 1.10, 100, 100, 140, like that, it keeps on increasing. So there is no continuity, no ending, and no one proper sequence. So such numbers we cannot express in the form of p by q. Such numbers are called irrational numbers. So this whole the numbers, that means natural numbers, whole numbers, integers, and rational numbers, irrational numbers, all together is called real numbers. Now in this chapter we are having some different types of examples we are going to discuss. That is about first finding LCM and GCD. So LCM from the beginning onwards, that means from 6th class or 5th class onwards, we are studying what is LCM, least common multiple, and HCF or GCD, whatever it may be, we will call it as highest common factor. So with the help of these two, one relation will be when these two are going to find for minimum two numbers. So LCM or GCD, we will find at least for two minimum numbers. So the two numbers, if you take A and B, so A and B product of two numbers is equal to LCM and HCF. So this is the relation between LCF, LCM and HCF, and the remaining two numbers, and what we are going to find. Now this is same thing, finding of HCF by Euclid division lemma. So Euclid division lemma, what we will take it is out of two numbers, what is the biggest number? For that biggest number, or that number, whether the smallest number which is given another number, whether it will divide or not. Suppose if you take 40 and 60, so we have to find LCF for these two by Euclid division lemma. How to find means, see this 60 is equal to 40 into 1 plus we will get 20. So here we will take again 40. So 40 is equal to 20 into 2 plus 0. This is called remainder. So when you get the remainder, then here automatically what number we are taking, that number will be HCF. So this is another method or another model in this topic we are going to discuss. Now coming for irrational numbers, already at the beginning I explained what are irrational numbers. So in this irrational numbers, some examples we will have, that is they will ask us to prove root 2 is irrational or root 3 is irrational. So some examples are there. So root 2 is an irrational, already we know, but they will ask us to prove whether it is irrational or rational. So these sums we will prove with the help of a contradiction. That means we will consider root 2 is rational, and at the last we will our assumption is going to be wrong, so that's why root 2 is irrational. So in such a way that we are going to prove these sums. And after this topic, in this chapter again we are going to discuss about logarithm. So logarithm is nothing but the reciprocal of an exponent. Say suppose if you take a power x is equal to n. So this logarithmic expression we will convert into, the exponential notation we are going to convert into logarithmic notation. How to convert means, see here a is the base, so here we will take logarithmic of n, the same base we will take here a is equal to the value of x. So nothing but the reciprocal. See here a power x is equal to n we will take, and the same x value we will get it as a log base n. So in this topic some important formulae are there. So that formulae are, the first one is log x y to the base a. That means when two elements are a single number, suppose a bigger number is there, if you split into smaller numbers, how to convert into logarithmic expression? See, that is equal to log x to the base a plus log y to the base a. So suppose here there is no base is given, we will consider the base as 10. So in the logarithms, log xy is equal to log x plus log y is the fundamental formula in this topic. So now, any number, suppose here the bigger number, suppose 1 lakh or some bigger number, if it is given, that bigger number is splitted into 10 factors. So here log a, b, c, d, e, f, g, h, like the 10 numbers if you take, you will get log a plus log b plus log c plus log d, and so on we will write. So here how many elements are there? That many splits we will get here in this formula. And coming for the next formula, that is log a by b to the base x you take. So now this is the number, a bigger number here we are splitting into different type of factors. Coming for here, whereas here it is a fraction a by b. So this will be taken as a log a minus log b. So that means log numerator minus log denominator. This is the one more formula in this topic we are going to discuss. And one more thing, logarithmic of a power m to the base x. If you consider here, the power is there here for the given number. So how to express this power means, this power we will write at the beginning. So that means m log a to the base x. So these three formulae plays more important role in this topic of first chapter. That means log a to the a power m by x is equal to m log a. Suppose sometimes we may have doubts. So if you get here the exponent, that means in the form of exponent, what is the formula? See, log a power m base b power n if it is there. So what to write? So already I explained here, m will come here. So this n also will come here. This number will be in the numerator and this number will be in the denominator. So that you will get m by n log a to the base b is the formula. So these are the four formulae most importantly we will discuss in the first chapter. And coming for the last but not least, in this one, two more important quotations are there. What is that one means? Logarithmic of 1 to any base. See, logarithmic value of 1. So base may be 1 or 100 or x or y or z, something you take, its value is considered as 0. And logarithmic value of same value, that means a to the base a, its value is 1. So these are the important topics which we cover in the first chapter. Discuss in this chapter.